Everybody knows this is GroupBy. You've been watching videos all day, and you've probably seen the code of conduct. Be nice, be good people. That's really the bottom line there. And we really thank all of the sponsors today for making this event happen. We really appreciate their investment in the community and also for making great products and providing wonderful services. I'm Kathi Kellenburger, and I work for Redgate Software, and I'm the Simple Talk editor and also a DevOps advocate. It's probably like 80% editor, 20% DevOps advocate. I'm co-leader of the data platform WIT group, and my passion in life is being an instructor at Launch Code in St. Louis, where I help lift people who love computers but haven't had the right background or haven't had, the education, and lift a lot of people out of poverty into really good paying tech jobs. So I teach T-SQL to several groups of people throughout the year. And I'm a lifelong learner, and when I learn something new, I love teaching someone else. You should see the number of hobbies I'm trying to learn and teach to my grandkids lately, like cookie decorating and ukulele and all kinds of things. All right, so we're going to talk about modern T-SQL. And I'm going to cover several problems. This typically is an hour session. There's some bonus material at the end showing some of the intelligent query processing. That's what I was just talking about a minute ago before the session started, how I wanted to see those features expanded. So if I have some time, I'll go ahead and cover some of those as well. So why are we stuck not using some of the new features of T-SQL? Sometimes we look at a problem and think the only way we can solve it is with some kind of a loop. We know it's slow, but we can't figure anything else out, or maybe a really slow self-join. I've seen places that had nested multiple layers of scalar UDFs and help them unwind that to really solve some problems. So the issue is that when you've got a problem to solve, you're going to use the tools that you know. You're going to reach for methods that you use every day, and you may not have paid attention when new features have come out. And most of the things that I'm going to show you today have been around since 2012. To me, that was really a great release of SQL Server as far as new functionality. So, that's really the problem, and I get it. It's easier for me to do something the way I know rather than go out and research something new. And that's one of the reasons that I like presenting, because it always kind of keeps me on my toes a bit. I'm typically giving a presentation about new T-SQL, or maybe I'm writing articles or books, and that's how I've kept it up. And I can't expect all of you to do that. So that's really the reason for this talk. So the first problem is called the stock market problem. And this one is really something in a fond place in my memory. Back in the day, around 2008, 2009, SQL Server Central ran a contest called Speed Freakery. And there were some gurus, some absolute T-SQL gurus, who would come up with answers to these problems, and they were just so fast. And the problem was that most of us could look at these solutions and not have a clue what they did. Nobody was really learning anything from those solutions. So the way it worked is that you would have the parameters of the contest, basically the problem you're trying to solve, and also data and a cursor solution, so that you could compare your results to the cursor solution to make sure that your answer was right, because that was the first thing, right? It has to be right, and then it has to be the fastest. So Redgate approached me and said, because they had seen I had written a lot for SQL Server Central, and they approached me and they said, you know, you're pretty good at explaining complex topics. Would you take a look at these contests and see if you can figure them out and explain what in the world is going on? So this was one of them that I took a look at. So the data looks, oops, oh no, I am telling the wrong story. I need to back up. I feel so bad. I told you the subscription story, which is here. So forget that story. The stock market story has an even more interesting, another really fond in my heart. The stock market problem was because I was doing some consulting work. I was an ETL developer at this particular company. And the DBA there would scrape the data off the web and import it into SQL Server. And then he was trying to figure out the closing price from one day to the next. And he came to me to ask for help. A couple months later, one of my colleagues where I was working, a junior consultant, came to me and said, Kathi, I've got this data that I'm pulling from the web. I'm importing it into SQL Server, and I need to compare the close price from one day to the next. You may think I'm making this up, but it's absolutely true. Two people with no really connection at all were doing the same thing, and both of me tried to figure this out. And I realized I was telling the wrong story when I saw this data. I'm like, wait a minute. So this is what the data looks like. There's also an open price, but the open price from one day is from what, like the close price from one day and the open price from the next day is not necessarily the same, because something could happen overnight to change the price. So this is a ticker symbol. All the data is made up, and there's a series of trade dates and close prices. So the results I'm trying to get is to pull the value from the previous row and then do a subtraction here to get the difference. And I want to make sure that these values don't overlap. So in other words, I don't want to compare Z1 and Z2. I only want to compare all the Z1s. So let's take a look at how to solve this problem. I have got 3 years worth of data, 999 symbols, all made up, almost 700,000 rows. And this is what it looks like, okay? If I want to look at one particular stock, I can see that I've got closed prices that are similar. So I just had some little script to create all this data for me. The open price, we can just ignore that. So how would I solve this problem? Well, my first thought is to do a self-join, because I need to compare two different rows from the same table. So I might do something like this, where I'm saying I want to compare on the ticker, join on the ticker symbol, and in the where clause, you know, one trade date is greater than the next trade date. And I believe this thing will run for a really long time and give me the wrong answer. Okay, so this is the previous, I could just change that to previous price. It makes more sense, but it's going to run forever because the query is just not right. I'm going to pull up every B except for, you know, just one, the one that matches here. It's less than that one. It's not going to work. I could create a temp table and run a cursor, and I'm just going to go ahead and run it just for a few seconds, not for 2 minutes, but I'll let it run for a little bit. So what this does is, you know, declares my cursor. I've got my variables there. I've got a little table where I've inserted the stocks, and basically it just goes through comparing to see if it's on the same ticker symbol and does my little calculation and updates the table. And I let it run 22 seconds. That's long enough. And I do have some right answers, but if I scroll down far enough, at some point I'll see, I thought, did it do the whole thing? Maybe it did do the whole thing, which seems strange. Sometimes it does run faster depending on, oh, this is saying 206. So I needed a lot more rows. It's got 255 rows and evidently I need a lot more for it to be correct. So I'm just not going to worry about it, but it is a slow solution. The other solution that I might try, and here I'm doing it just for 4 different stocks. I'm using outer apply and I'm using select top 1. If I just used select top 1 with a join, I'd only get 1 row back. So what I'm doing is for every outer row, for every row in the results, I'm going in there and I'm pulling out a top 1. So it does take a while to go. And it ran in 5 seconds. However, that's only 4 symbols. So it just doesn't scale. It's really, really bad. So here's the solution that I came up with. I use the function lag. Lag is absolutely my favorite function. You might have a favorite band, you might have a favorite movie, but I've got a favorite function, lag. But with lag, I don't have to join the table to itself. It allows me to go and grab another a column from a previous row. I can go back in more than 1 row. By default, it's just 1 row. So here I've got the whole function. It's kind of long if you haven't seen this before. The really important part here is this over clause. The over clause tells SQL Server basically what to grab, which row to grab from. I want to partition it or create separate sections based on the ticker symbol. And I want it ordered by trade date. And the reason I want it ordered by trade date is so I will always know, how to get to the previous day. And then I start with the close price and I subtract that exact same function call. So I'm going to run this. I don't have any filters. I'm not going to stop it early. And it's running, shouldn't take too long. So in 10 seconds, I was able to process almost 700,000 rows. This one, we had 5 seconds for only 4 rows. I let the cursor run for a few minutes. It only processed 200, not really a few minutes, about 20 seconds. It only processed about 250. So it's a really, really great solution. And it's part of SQL Server 2012. When I go around and where I used to go around and present on window functions, this is one of the window functions, pretty much no one in the room had heard of lag. And there was typically a lot of excitement about it because folks have problems. It's just very typical problems that they need to solve, and lag can come in very handy. There's also lead. Pop back to the lead will let you go forward in the rows. These are new with 2012, and the over clause is what's really important. So are there any questions so far?
There are not yet. Actually, one just came in as I was saying that.
Okay.
So it says, will your lag close price in the best solution be calculated twice once it's twice in the select list?
Yeah, it will, but it will not slow it down. It won't make any difference. I'm not sure under the covers if SQL Server is actually calculating it twice, but it's not going to run any slower if I just have it in there once or have it in there twice. The real difference is if for some reason I would have lag close price, but my over clause would be different, then I'd start seeing an impact on performance. So as long as the over clause is identical, it shouldn't matter whether I have one or two.
Okay. And then something just came in the Q&A, which I would say is more of a request than a question. But it asks you to show the query plan, if that's doable.
Oh, yeah. For this one? Yeah.
I believe so. It just says show the query plan. So
Yeah. I gotta stop it here and do that. And we're waiting. It's taking longer to run now than it did a minute ago. You never know on a laptop what's going to happen. We've got this window aggregate, which is relatively new. Probably you got the table scan, which makes sense because I don't have a where clause. That's where most of the cost is. The sort has to do with that over clause. When I see window aggregate, I am really happy usually. And I'll explain more later when I get to the bonus stuff about this. But basically, it's probably taking advantage of that batch mode on row store. Is possibly why that's coming up.
And I've got one more that just came in if you want to take it now or if you want to wait until the next break.
Okay, go ahead.
It says, how about performance of window functions when doing calculations on them? Example, lag, close price minus lead, close price, both
Shouldn't
on the
matter.
same and different partitions.
On the same and different. You cannot do it on different. You cannot nest window functions. So I could not, I guess I'm not quite sure. So I guess what they're saying is if I took this and then subtracted this, but the over clause was different, I guess.
Yeah, I think it basically, yeah, if you subtracted one window function from the other, you know, how would performance look? And if it was crossing partitions, would that have any impact on kind of
like
how I read that?
Different partitions, partition by. You'll get a hit, you'll get more sorting because for the over clause, the data under the covers is sorted to do this. So if you have different over clauses, whether you're subtracting or not, you're going to have a hit on performance due to the sorting. If we were subtracting different columns, you know, be fine.
Yeah. So nothing in there for now. Obviously, folks, keep those coming in the Q&A pane, but I will quit running my mouth.
Well, I think I was running my mouth. So here's a subscription problem where I told you that whole story. This is the second time that I've ever done this. You told a completely wrong story to start with. But basically, this was that speed freakery that I started off with, where Redgate asked me to help solve the problem. And not really solve it, but explain it. That's more accurate. So this is what the data looks like. I have a registration ID. I have a date that they joined, and it could be any time within a month. We're going to count that as that month. And also when they stop their subscription. So it's really a running total type. We're going to take whatever the previous subscription was, add the number that joined, and subtract the number that left. And this is basically what the results should look like. The month needs to be normalized in some way. You could split it apart and say year, month. The original solution that was done, he normalized it on the last day of the month. Okay, so that's what he did. So let's take a look how that was. I think I have the original solution here. All right, so what's really interesting is back in 2008 or 2009, the original problem had 10,000 rows. And I have struggled to make anything with 10,000 rows run slow enough to actually measure the difference. You know, not only do we have better functionality, we also have better computers, right? Because now we've got more multi-core, we've got more RAM. So I decided to go with 1,000,000 rows, and this is just all made up data. And I had to, and because it's based on year and month, I had to create a pretty big time period as well to make a difference. And I'll show you why in just a minute. So I went back to like 1970. And just to show we do have 1,000,000 rows. So one thing that you can do, and this is really important with many, many queries that you write, is in some cases you can do some pre-aggregation to really help. You know, you can, like some of the windowing functions don't perform that great. Not all of, lag is like one of the best. Some of them aren't that great. So that's another thing that can help there by pre-aggregating down. And when you apply the window function, you're only applying in a small number of rows. So one thing that you could do to get started is create 2 queries. One, to look at the new registrations by month. And here we just have the dates split apart. And we could also have another query where date, where we count the cancellations. There is one thing that I need to point out is that every month, there's no months with cancellations that don't have subscriptions. It does make a difference down the road. That may not be realistic, but that's how the original data worked. You have a bunch of months with registrations. Some of those also have cancellations. So one way you might try to solve this is with a self-join. Here I've got a common table expression with the registrations. I also have a common table expression with the cancellations. Here I've got multiple layers here. I'm joining, and next one, I'm joining these 2 tables together, date joined and date left. And finally, in the outer query, I am doing a running total. I'm not going to let it go too long. And based on that data. So I basically have, you know, pre-aggregating, then join that together, then do a running total. And I'm just going to kill it because I think it would just take way too long. Maybe I could use a cursor. This is the solution that was given to all the contestants. I'm not going to explain how it works. But what I found was that it really did not take too long to run. I'm not sure if we'll get through the whole thing here before I decide to kill it, but it actually ran better than that self-join that I showed you first. Yeah, I'm not going to wait. Trust me, it is correct. All right, so here's the winning solution by Peter Larson. He won several of these. He is very smart, way smarter than I am. And he created a couple of temp tables, or he created a temp table, inserted the date joined and date left numbers, grouped it, then he declared the subscribers int And then there's this quirky update that had a ton of controversy. Basically, not only we're setting this value kind of as the query runs. So it's a running total. So he's got the subscribers equal the subscribers equals subscribers plus people join. And I looked at that and I'm like, what in the world is going on here? However, whatever he did, it's exceedingly fast. It was about 1 second to process all 609 rows. And the previous two solutions that I showed you here, I just killed because they were taking too long. You know, I let them run, they would eventually come up with the correct answer. So there was a lot of controversy about this because theoretically this quirky update is not necessarily supported, and maybe down the road it will not work correctly. But again, this is 2009. We don't have a lot of options yet for running totals. So this is the solution one of the solutions I came up. So what I had done back around 2009, 2010 with my article is that I explained what he was doing. And then I also came up with another solution that was almost as fast as his. You know, wasn't quite as fast, but it was like within a second. It wasn't taking minutes to run like the cursor. Then again, I went back later after 2012 came out and said, hey, wait a minute, these windowing functions are pretty handy. I'm wondering if I take what knowledge I have now about these, can I apply them to these problems? So I ended up going back and writing 2 or 3 more articles explaining an easier way. So with the functionality in SQL 2012, it's so easy. It's like, I can't believe we had to struggle so much. So the modern solution, again, I'm using common table expressions here. We were just talking about them earlier. A lot of times they don't perform well. In this case, they're fine. And I'm doing the same thing where I'm getting the new subscriptions. I'm grabbing the cancellations. And I'm joining the two together. It's very similar to what I showed you in the beginning. The difference is I'm using the Windows aggregate. Here I'm doing sum over with an order by, and I'm using rows between unbounded preceding and current row, the frame. So I'm using this syntax to very quickly run, you know, query should run pretty quickly, maybe not quite as fast as Peter Larson's. But let's see. Yeah. Oh, actually, this time it ran a little faster. Might be due to caching. Probably due to caching, because I think his is really faster than what I've done. But it's so easy. The original solution I showed you way up at the top, I go here, way up here, let's see. The self-join, the problem is that we're doing this, you know, we have to find the top one, or you have to find not the top one, but the ones that are less than, and you know, it just gets really awful. It does work, but it just doesn't perform well. It doesn't scale. But with using the windowing function, it does. So I'm doing sum over, and I've got a little, I don't have to use just one column here. I've got a little expression. And it would give me the right answer if I just used order by without putting this frame. The problem is you are, depending on which version of SQL Server, which version in addition, you will get really crummy performance if you leave this out. So I was pretty excited when I found a really easy solution based on window functions after I went back, a few years later. So Matt, are there any questions?
There are not at this time, either in Q&A or chat. So if people have them, keep them coming. But right now you are good.
All right, thanks. And if some of this stuff I've been talking about with these windowing functions looks weird, you haven't seen it before, you might just do a search, because I have 2 talks that I give just on windowing functions, and also have a book out. So if you do a search, you should find more information. All right, so one of the things that Peter did when he solved the subscription problem was consolidate the date, or really normalize the date on the end of the month. Let me just run his whole thing again, just so I can show you. Original winning solution. Okay, hopefully this is going to work without me needing to type in a drop. There it is. Okay. So this is Peter's solution, really fast. And so what he did the first of the month, not the end. So he normalized the solution on the first of the month. So I said that wrong earlier. I just forgot. First of the month. My solution, I normalized it on the last day of the month. And there's a reason that I did that. And that's because there is a function that was introduced in SQL Server 2012 called EO month that will give you the end of the month, whatever month it is. This is a group of, one of a group of functions that I like to call the easy functions. The catch is, even though they're easy, some of them perform well, some of them don't. So you really have to be careful. The end of month function is one that did perform really well. So let's take a look at that. That would be number 3. So what I did is I listed a few of those, like there's one called IIF or if. I can't imagine ever using that. It's similar to working with the formula in Excel, where you can, if something is true, do this, if it's false, do that. I personally can't imagine ever doing that. I would always use a case. There's one called concat. I love concat. It takes care of a lot of things for you. For example, if you have to concat some strings, concat columns, and there could be some nulls, it takes care of the nulls for you. It takes care of converting data types, casting data types. So, and it performs pretty well. I think I have some examples here, or at least some results that I did. There's one called format. I like this one on a small amount of data. Doesn't scale very well. There's one called string split. People seem to hate this one. I kind of like it just because typically I'm going to be working with reporting services where I'm sending over a list of like 10 or 20 comma delimited items, and string split is going to perform really well on a small amount. Maybe it doesn't scale, but I have never really needed it in for any big amount of data. So again, you just have to be careful and do some testing and make sure that these things will work for what you want to do. And then of course, EO month. There's some other ones, but these are kind of the ones that I thought of. So first of all, I want to take a look at the way we used to, one of the ways that we could come up with the first of the month or the end of the month by tearing the date apart and basically putting it back together. And I've seen code like this where it just is so messy, and I look at this and I have no idea what I'm trying to accomplish, except for the fact that I did have a nice name on the column. So really to test this, I need some bigger data, some bigger table. So I like to work with Adam Mechanic's Thinking Big Adventure table. And he has about 31 million rows. Then I like to make some smaller copies of it. So what I'm going to do is calculate the end of the month from this table. I'm just going to throw the results into a temp table so we don't have to wait for 7.8 million rows to populate the screen, and just see how long it takes. And in this case, we're tearing the data apart and putting it back together. And it's really taken a while. There it goes. And we can see that it did work by querying the temp table, and it did work. I'm going to do this just to make sure we're not cheating. And I'm going to use, instead of that ugly formula, I'm going to use the EO month function. It should be much quicker. I forgot to pay attention to how long it took on the other one, but it's done already. It's done in 6 seconds. The original, let me just run that original again. I forgot to really notice how long it took. And I didn't clear the buffers out either that time. So it's actually got a little head start. So it's 11:13. So it took twice as long. Here I'm going to go ahead and try to run it on that entire table of 31 million rows and see what happens using EO month. Remember, it took 6 seconds to do 7.8. And I'm hoping it's not more than like 20 seconds because I will not want to wait. It's around 20 seconds. Come on. There it goes, 25 seconds for 31 million rows. So I think that's pretty good. It has more data to work on. So that's why it did take longer than just 7.8, but it's like basically scaling very linearly. And so I feel comfortable using this EO month function as opposed to some kind of formula that tears the data apart and puts it together. Always test, because you may run into something that I didn't test myself. So let's look at concat. So one thing that you might run into when you're trying to concatenate it, really anything, if you run into nulls. So the first one, I'm using concat. The second one, I'm just using just the plus. And notice whenever there's a null middle name, I lose everything. Concat takes care of that for me. But other thing I'm doing here is putting my space right here, because if middle name is null, the space goes away too. So concat works pretty well. Here's a situation, and I cannot really compare it because if I don't cast it, it won't work. So I've got business entity ID. It's an integer. How do I concatenate that? How do I add that to the name? Well, if I'm using the concat function, it just works. It does the casting for me. And it looks like I've got a little demo where I'm going to see, maybe I won't run it. Actually, I got lots of extra time in this session, so we'll go ahead and do it. So what I'm doing here is casting. I'm using isNull, or I could use coalesce. I think we'll have the same results. But basically doing this the typical way that you would do it. It says up there it took 34 seconds. I don't know if we want to wait 34 seconds, but we'll wait at least 20. Let's see how long the other one would take. A little bit faster. So this, by using concat, it was a little bit faster, not a lot faster. But what I found was the more manipulations I had to do, the bigger the difference. So here I've gone from 2 down to 1, just using the concat function. And so that was 46 seconds. So by using concat, instead of, let's say I had a lot of places where I had to use coalesce, or I had to do casting, using concat would be not only easier, but it would perform better over using multiple. But when I did some testing, it was like the more manipulation I had to do, the worse the query got, where concat really didn't change that much. Up to, hope it doesn't take 45 seconds like the other one did. But I did lots and lots of testing. This has been a few months ago, and I got pretty consistent results for that particular day. My computer just must be running a little bit slower right now, 40 seconds. So a little bit faster. Format, I saw worse. This is on a, actually wasn't bad. Oh, that's on 100 rows. That's why it wasn't bad. It's only on 100 rows. But if I tried to do the entire table, looks like it would take quite a while. Probably about, looks like it was over 30 seconds. And I'm tired of running this. So here I'm just using the convert function that I really love. A lot of people hate convert. They'd rather use cast. But if you've never seen it, and this is something that goes way back, I'm not sure when it was introduced, but there's these different styles that you can use. So let me take a look at how this looks. That took 42 seconds. But here, style 101 looks like this. And if you go out to just do a search on cast and convert, you'll see a table of all these different styles and what they mean. Oh, it is something still running. Oh, just looking at those, just populating those 31 million rows takes a long time. I'm not going to run this next one, but doing the same kind of thing, just formatting a date using format, took a whole lot longer. So if it's a little bit of data, not a lot of rows, great. But if we're talking millions of rows, it might be a bad idea. So Matt, do we have any new questions?
We have one.
Okay.
So yeah, it says, do you have experience with window functions together with union operator? We recently found that it is a performance killer on Azure Synapse. Just wondering how it behaves on regular SQL Server.
Well, if you just say window function, I don't know which one it is. It might be the volume of data. Like if it's just a regular window aggregate, I can see that being a problem, but I don't know. I haven't really worked with Synapse, so I don't know if there's any direct correlation between, the syntax or anything. I haven't worked with it. It shouldn't matter. Like if I have one query that's using a window function and the other one is using a very similar window function, it shouldn't matter whether they're unioned or not in SQL Server. It depends. Now, if I'm using a window aggregate, they don't scale really well. If I'm using lag, you saw how they do scale. So there's so many depends in there.
So the classic answer, as always,
right? Answer, it depends. Yeah,
yep.
Because with windowing functions, there's a bunch of different types, and each one has its own peculiarities as far as performance. But union shouldn't really matter in SQL. I don't know about Synapse at all.
Okay. There's nothing else out there right now. So yeah, if there's more specific details to be thrown in on that question, feel free to do so in the Q&A panel or in the chat. But I'll turn it back over to you.
Thank you. So I had to include the islands and gaps problem because I love this photo. This is my own photo that I took in Hawaii back in 2018. And it was my dream, my bucket list item, to take my kids and their families, and I took my husband to Hawaii for vacation. It was wonderful. I don't recommend taking toddlers to Hawaii though. Not always easy. But part of my dream was to renew our wedding vows on a black sand beach. So this is where we did that. And we used the Klingon wedding vows. We did not have the batlet. We were not attacked. We just used the words, which I think are very beautiful. So if you're a Star Trek fan, I'm talking about when Worf and Dax got married, those vows, without getting attacked at the end. So that's why I love this photo. So the islands and gaps problem, what in the world is it? So this is just, I believe this is probably just a classic computer science scenario where you have this data that's lined up. It might be dates, it might be numbers, and you need to find where the numbers are missing. Those are gaps, or where we have contiguous numbers or dates, and those are islands. So what I was really learning about windowing functions, just really starting to wrap my head around them. And I have to thank Itzik Ben-Gon, because he really educated all the rest of us about these, and including myself. I started just different problems that would come up, and I'd say, what if I just throw a row number in there? What would happen? Well, I see a pattern. And so when I tried to solve the islands and gaps problem, I did not look at anyone else's solution. I just came up with it. And so I just want to show it to you, not that this is anything with performance, but just my mind, steps my mind would take when I'm solving a problem like this. So let's take islands and gaps. This is just a small amount of data that we're working with, but it, should work with even more. So I'm going to create a table called some numbers. It's a little more complicated if you use dates. The patterns and ideas are the same, but it's just a little easier to show with numbers. So I'm going to insert some numbers into this little table. And if we take a look at the numbers, we'll see that we have an island from 1 to 5. That is an island. Those are contiguous numbers. We're not missing anything. And then we have another island from 8, a little more, 8 to 11. We have an island that's 13. We have another island 15 through 17. So how do I write a query that gives me results that look like this. So like I said, I like to just throw a row number in just to see if there's any patterns. And the interesting thing about row number is I was using it for years without realizing anything about the term window. I kind of switch back and forth between windowing. I never realized that this was a special group of functions. I just learned how to use it. And when I give presentations, a lot of times I'll say, does anybody know what these windowing functions are? And maybe only a few people know. How many of you use row number? You know, usually 3/4 of the room raise their hand. So it's used a lot. So first thing that I'll do is just take a look. I'm comparing the number to a row number. And all I'm doing, I'm not doing partitioning. I'm just ordering by the number and just to see what happens. So when you look at this, you'll see that these numbers are equivalent until we get to the next island. So 1 through 5 was our first island. 8 through 11 was our second. All of a sudden now we've got a difference of 2. I look at this one's by itself. It's got a difference of 3. And finally, I have a difference of 4. I'm seeing a pattern. I can do something with this. So the next step is I just went ahead and did the subtraction. And I'm calling this different group because guess what? I can group on this value and get the minimum and the maximum. And note that's my, first number in my island and my last number in my island. So what I did was I took that query I had written in the last example, threw it into a common table expression. And then in the outer query, I took the min as the start of the island and the max as the end, and I grouped by that difference. You may be wondering why I didn't just use one query. Why am I separating out the logic? And it's because, you have to separate out the logic. I can't, so here I'm, figuring out what the difference group is and all of that. I can't group on that directly. I've got to separate the logic out in some way. It could be a temp table, it could be a derived table, could be a common table expression like I'm using. So in order to do that, I've separated it out. And then here's my answer. So really not too difficult. The other thing we need to figure out is the gaps. So when I'm looking at the islands, just looking, I see a pattern. If I want to find the first gap, I can say, well, I need to add 1 to 5 and subtract 1 from 8. And I come up with 6, 7. Okay, so I need to add 1 to the end of the previous island and subtract 1 from the beginning of the next island. And I need these on the same row. So hopefully you're thinking of lag, where I can take something from one row and compare it to another row. So I'm going to go ahead and take everything that I worked with before and just move it up into a common table expression. So here's where I found the island. And in the outer query, I'm using lag to go backwards. I can just subtract 1 from the current row, but I need lag to go backwards to add 1. And it works, except I've got this that I don't really need. So what I did here, you can probably guess, I went ahead and moved the gaps part up into a common table expression, and then just put a where clause here. Later, I realized, well, I probably could have used the where clause on this part. Could have done that. So let's run it and see if we get the right answer. And that one is eliminated. Any questions, Matt?
Well, if I could find the mute button, that would be good. No, there are no questions in chat or Q&A at this point.
I forgot to tell you one thing about this Hawaii story. We're walking away to the car after our ceremony. My granddaughter at the time was 6, and I'm holding her hand, and she looks up to me and says, "Grandma, are you and Grandpa going to have kids?" I'm like, "What?" So, I mean, it was just so hilarious. Not now. We had them already. All right, so the next item I want to talk about is intelligent query processing. This is kind of bonus material, depending on how much time and questions I have when I give this talk. So since I do have until my time 5, I'm going to go ahead and see how far I get. So intelligent query processing just means some things that Microsoft is changing about the optimizer to make really it works on some of the anti-patterns or some of the issues, some of the things that don't perform that well, that are pretty common. And this is the graphic that you'll see if you go out and just really anybody who's talking about this will probably show this graphic, or if you just go out and query it. So this is from Microsoft's page. And there are some things that came out in 2017, some in 2019, and there are some of them that are Enterprise Edition only. What I found is if the group has anything to do with the word batch, they're typically like memory grant feedback is going to be Enterprise, batch mode and row store is Enterprise, and adaptive joins. That's the word I was trying to think of at the beginning. Adaptive joins is going to be Enterprise. I'm hoping that changes, because if we could, especially this adaptive join, that could really help a lot of people. And that's one of my things that I have requested is, can't we get this to row mode? You might be thinking, well, what's batch mode? What's row mode or row store? Batch mode means that there is a common table expression involved. Batch mode is a feature of common table, not column store index. Hopefully I didn't say common table expression too many times. Column store index. Okay. And it's not parallelism, but you can kind of think of it similarly, where the problem is broken down into smaller pieces. This involves aggregations and very high numbers of rows. Okay. So in 2017, they got this thing called adaptive joins, but it only works in batch mode, which is column store index, right? Memory grant feedback. Well, it was only in column store, but then in 2019, they extended it to row store. Batch mode and row store is taking that functionality where they're breaking the problem apart on large aggregations, but it works on queries that don't involve a column store index. Okay, and none of these, except for one, approximate count distinct, except for that one, none of them require any changes to your code. They just work. Again, you got to test. You may run into some issues where they don't work the way that you want. And Microsoft makes it really easy to turn these off and on. You can turn the entire set on by changing the compatibility level, or you can change a database property to turn any particular one completely on or completely off. And you can also use hints at the query level if you want to not use one for a particular problem. So let's take a look at some examples. Let's see. Let's talk about adaptive join. And I'm going to use the Worldwide Importers database on this one. And I based my example on the query from the documentation, but what I found when I tried to run it is my data evidently was not exactly the same as what they used for the example. So I ended up having to delete some rows to get it to work. And I better go ahead and do this just because I may have restored that database recently, just to make sure that I've got it. Okay. And I like to just throw it into a stored procedure as well, just to make sure that I'm always running the same thing without worrying about extra spaces, things like that. So this query that I got from Microsoft's example is joining fact order, which is a column store. It's a column store clustered index, or clustered index column store, however you say it. And we're joining to this dimension table that's a regular table. And we are sending in a quantity. I'm going to change the compatibility level down to 2016 because this new feature came out in 2017. And you're going to love this. I'm going to turn on the execution plan. I'm going to free the cache. I'm going to run this one with a quantity 360. I get back 206 rows. When I look at the execution plan, I see that there's a missing index suggestion. I see that there is a clustered index scan, and here's where the filter went, the predicate, and there's a hash match. So this is the correct plan for this particular parameter. If I run this one with the quantity 78, I'm actually getting back no rows, which is not what I wanted. I wanted a few, probably because I should not have run that. But the difference is, there's no difference because this particular plan is now cached for this stored procedure. So I still get a clustered index scan. I still get a hash match. Identical query plan. I'm going to free the cache, and then I am going to run these in the opposite order. If you've done a lot of query tuning, you probably know what's going to happen here. So this time, I've got a nested loop. And I don't have that separate filter. The seek predicate is pushed into that clustered index scan. That's the right plan for 78. But when I run 360, remember we needed a hash match for that one. I'm stuck with nested loop. So that's a problem, parameter sniffing, right? So what I'm going to do is I am going to change the compatibility level. I'm going to run these again. This time, remember, we would like to see a nested loop. But we don't see either one. We see this strange looking thing called adaptive join. So let's see if I can bring the properties up and look at it. So it's telling me that it's this adaptive join, but it actually used a nested loop. Okay, that is what we want. If I look down here, the odd thing is I will see two different paths, two different data paths. And it actually went through this path. Okay, so I see two different paths. I see this adaptive join that can switch. Let's see what happens if I do 360. This time, this is the path that was taken. Properties. This time, it was a hash match. So I'm really excited about this. Problem is, we need a column store index involved in the query to get this. And this is one of my requests that I said, hey, I would really like to see this expanded to be used in row mode. Any questions, Matt?
There are not. There's an interesting discussion about why the Synapse performance might not have been so good, but that's in chat. So no,
yeah, leave me out of that
questions for you. Yeah.
Okay, sounds good. Let's take a look at. Let's see. This one was adapted joins. Scalar UDF inlining. This one has got some controversy going on. In some cases, it's not working correctly, but where it does work, it's amazing. So most of you know, if you create a scalar UDF, and in some cases, table valued UDFs don't always work great. It depends, but scalar UDFs are used a lot to kind of encapsulate code for reuse. And I've seen, these things nested multiple layers and just all kinds of craziness. I've spent time unwinding them, trying and saying, hey, there's no reason for this to be a scalar UDF. The problem is, for every row in the results, SQL Server runs that UDF. It might even give the same, and that was what I was seeing at this one place. It was using, for the parameters of this UDF, there were hard-coded values or something that they had figured out earlier, but they still used it instead of just an answer in this query. And just realizing that and fixing that shaved a lot of time off that query because it was calculating the same thing over and over and over. So what I'm going to do is change the compatibility level to 2017. And I'm going to, again, like I did on some of the other examples, I'm going to toss the results. I don't want the whole results to populate here. So I'm on a team, and we have a lot of financial calculations. And here's this markup, or actually retail calculations, I guess. We've got this markup calculation. And we run this query all the time. This formula is used constantly, not just in this query. And we get pretty good performance. This is a big table. And I'm not showing you the results. I just threw them all into this test table. But it runs pretty well. It ran on this decent sized table in 7 seconds. So we're happy with that. Well, we decide that because we use that formula all the time, let's create a function and just start using this function and replacing it every place that the formula is used. So it's exactly the same. I'm not running any queries inside this function. All I'm doing is this little calculation. So we go ahead and run some tests. And all we're doing different here is that we're now using this UDF get markup function instead of the formula typed out. Now, it's kind of silly in this example because you could, it looks just as messy, I think, calling the function, but you could have something that's really much more complicated. And it's still running, and it's still running, and it's still running. What in the world happened? Well, just by changing this to a function instead of the inline formula, we've slowed it way, way down. So then we haven't quite figured out what's going on. We're just not sure at that point. I know what's going on, but maybe the team doesn't. And we upgrade to SQL Server 2019. Again, we're going to use that function, but this time it should run really fast. So this time it took 3 seconds to run. So what in the world is going on? It's because by upgrading to 2019, which I kind of simulated just by setting the compat level, we're taking advantage of something called UDF inlining. So under the covers, SQL Server is just doing basically what we did in the first example. You know, kind of pulling that out of the function, not really, but kind of that idea, and running it as if it looked like this. So this is great. There's places that are using lots of UDFs. In some cases, this will help, but not always. There are, if you go out to the help on this, documentation on this, you'll find that there is an extremely long list of restrictions where it won't kick in. I'll show you a few examples. Here's one where I'm actually pulling from a table and I've got an if. This inlining works with this. You might be surprised about that, but it will work. So if I create the function, and this is not the same function that I was working with before. This one is actually very different. It's going out and getting the order quantity for a particular product for a particular year. And if you don't send in a year, then it figures out what the year would be. So it's got an if, it's got it's got variables, it's got a query. But if I use this, let's see, what version am I at? I'm still at 2019. Okay, I'm going to run it both ways here. Let me just grab this. I want to run it both ways. There we go. Move it down to 140 and run it. And I want to take a look at statistics IO. Hopefully I have set that. I did. So when I look at the statistics IO, all I see is the product table. But if I go back and look at that function, I'm looking at the sales order details and the sales order header table, but it doesn't show me that in my statistics IO. If I look at the execution plan, all I see is the product table. You got to really be careful. This is hard to track down, some of these issues. So it looks like it shouldn't even be a problem, right? So let's set the compatibility level to 150. This is a small table. We are not really going to see a big difference in performance. But if I run this, I believe, aha, I was right. I now see sales order header, I see sales order detail, and I get a very different execution plan that is much more complex, but at least I see more of what's going on. It's not a black box. So this inlining, that's what's going on. The inlining worked, even though I had an if, even though I was querying. If I add a get date, if there is a get date or anything like sys date time, any of those, where we're pulling the system time, it's not inlineable. Okay, that's one of the exceptions. And here we're using this new get date function. So let's take a look at this one. If I look at it again, I don't see product, I don't see the other tables. The execution plan doesn't tell me what's really going on. I could have a loop. Here's another exception. Doesn't work. You know, just looks like product. And we've got that little execution plan that's not really telling us what's going on. So there is a very nice DMV that you can use. Actually, I guess a system view that you can use. If you run this query, SQL modules, join sysobjects, sysobjects just to get the name. I'm filtering it just so I'm not pulling in a bunch of system functions that might be out there. And you can find out if it's inlineable. So with the very, let's see, the get markup was the very first one we did, is inlineable. If I added the if and a query, it was still inlineable. This is probably the first one I did, one of the first ones, or me, I'm not sure if I gave this. Yeah, I think that was the first one. And it was inlineable. So you can use this to decide. And if you run into issues, there are some issues with some of these, you can always use a hint to turn that feature off. So are there any questions?
Not at the moment.
Okay. There's just one more I want to show. I can really make a session drag out, can't I? Batch mode on row store. I don't know if I'm going to run this whole thing. I'll make sure that this is out on my GitHub for you to grab. But you remember I talked about window aggregates. So here's a window aggregate. It doesn't scale typically. But if you have batch mode on row store, it does. So I guess I could go ahead and run this. It kicks in for other things as well, but this is probably my favorite reason to use it. Oh, wrong. It will take a really long time. I'll just let it run for 10 seconds or so. This doesn't scale really well. Oh, it took oh, it's still going. Nope, 12. Okay, so that's not too bad. Could be worse. If I change the compatibility to 2019 and I need to either be running developer or enterprise, it's much faster. And hopefully I'm not lying to you here. And basically, so yeah, 4 seconds. So the other one wasn't too bad. So basically what it's doing is just taking the problem, breaking it down into smaller pieces, doing aggregations, and then pulling it together. And in 2019, we get this functionality in row store queries, where in 2017, well, really going back, I think to like 2014, possibly, it was column store index only. Any questions?
Nothing. No. It's
we still have that one debate going on.
Yeah, the Synapse discussion has added a couple more posts in chat, but
okay.
Nothing else.
All right, so you can go out to my GitHub and download the slides and code if you're interested. I think I need to, I'm not sure if I have all the IQP features up there. So I'll make sure tonight sometime to put those out there. And there's lots of resources. So this would be worth it to download the slides just to get these, or just take a quick screenshot or whatever. So Greg Larson did a series on the IQP features. Plus I've got a ton of articles and out there about windowing functions in general. So those are some resources. ITSEC's got 2 books. Am I mentioning my books? I'm not even mentioning. ITSEC's got a first edition and a second edition on windowing functions. I also have a first edition and a second edition on windowing functions. Buy both of them because we approach things in very different ways.